Alright, we're going to graph f of x and the inverse of f of x. And the way we're going to do that is by using transformations. So first of all, this graph right here, this red graph, I'm going to graph, the base graph for this is going to be f of x equals 2 to the x. And that one goes through 0, 1, right there. And it goes up exponentially like that. That's the base graph. The base exponential graph when the base of the exponent is greater than 1. Okay, it's always going to go through 0, 1. Because it doesn't matter what I'm putting as a base, if I raise it to the 0, what's b to the 0? It's 1. Alright, so now we're going to take this graph and do our shifts to it, and we're going to use the good old-fashioned transformations. That shifts everything 3 to the right, and that shifts everything 1 up. Notice that I had a horizontal asymptote of 0. Now the horizontal asymptote is going to be 1. X equals 1 is my new horizontal asymptote. This point, which was at 0, 1, now shifts up 1 and to the right 3. That's my new point, which is 3, 2. If you don't believe it, check it. Plug it in. Plug in 3 here. Plug in 3 for x. 3 minus 3 is 0. 2 to the 0 is 1. 1 plus 1 is 2. That's really the only point you need. I mean, your teacher might want more, but really that's all you need, because that gives you an idea of what your graph does. There's my graph. All right. Now they want us to graph the inverse of that. So I'm going to do this a couple different ways. First of all, I'm going to do it by drawing in a line, the line at this line right here. Yeah, my line y equals x. And if I reflect it over that, that's going to be my new graph. And that includes taking, so I'm going to turn this to green. I'm going to do this in green. So f inverse of x. Oh, that's not a very good green. Let me do it in lighter green so you can see the contrast better. F inverse of x. So this line, instead of x equals 1, is going to become y equals 1. Y equals 1 is my vertical asymptote. All of these points right here, now I didn't draw it very perfectly, but those points that are on the line y equals x are going to still be there, and it's going to do, this point is going to become 2, 3 instead of 3, 2, 2, 3, which is right there. That point's going to be on it because you just switched the x and the y. So 2, 3, there's my graph. There's the inverse graph. Now if you want to do it algebraically, you would take this equation, you would change the x and the y, the f of x and the y. I'll do this really quickly for you. You would change them like this, and then solve it for y. So x minus 1 equals 2 to the y minus 3. How do I get this out of the exponent? I take the log of both sides. And let's go ahead and take the log base 2, because then this will just go away, right? The log base 2 of x minus 1 equals y minus 3, and now add 3 to both sides. So y equals the log base 2 of x minus 1 plus 3. Hey, look at that. That had been a positive 1, plus 1, now it's a minus 1. That had been a minus 3, now it's a plus 3. That's not a coincidence. So your graph, this is your equation. Now I could have graphed that equation from that by taking my base graph of the log base 2 of x, which goes through this point right here, and then shifting that to the right 1 and up 3, and I would have gotten that point there. I would have gotten my new vertical asymptote at x equals 1, and I would have my graph just like I have it on the green there. So that's how you graph those, and that's 2 different ways of doing it.